everyone, welcome to Mr. Chin's class. Right, today we're going to go over the quotient rule. For the quotient rule, the original equation, it's in fraction, so fx function over gx function. Right, this is very similar with the product rule that we have done last lesson, but the only difference is that those two are multiplied and today it's divided. Okay, so how it works is once you see two functions in fraction, okay, what you need to do if you differentiate it, okay, find the differential of fx, put it there, multiply by just original gx, minus, it's always minus, fx, we just bring it down, times g dash. So differential of gx, okay, put it over there. And gx, we're not differentiating it, but just this value, I'm gonna square it at the bottom. Okay, so this is the formula that we should follow. It's pretty much very similar with product rule. So if you like the product rule, then quotient rule will be easy for you as well. Okay, let's have a look at the first question. So the top one obviously is fx, the bottom one is gx. So now I'm going to try differentiating those top and the bottom. Okay, so it's the first one, the top one, fx is 2e to the power 5x. Right, when you're differentiating this one, it will stay the same. So 2e to the power 5x, I'm just going to write it down as it is. And then what do? Differentiate the power, which will be 5. So I'm going to multiply it 5 like this. Okay, so if you simplify, it will be 10e to the power 5x. Right, and simple thing. Bottom one is gx, and if you differentiate it term by term, 2 comes down, 3 times 2 is 6x, right? And that disappears. So there you go. Okay, so I'm just going to follow the formula as it is. Okay, so let's have a go. I'm going to differentiate h dash, h function, okay? It's f dash, which is this, followed by gx minus fx and g dash, right? fx and g dash, right? My gx at the bottom over here is this one, 3x squared minus 4, and I'm going to square it. There you go. Okay, on the next line, what I have done is just that 2 times 6, which is 12. Should be 12x, but I forgot to put x, so there you go. I just wrote x here, but it doesn't matter because it's all linked with multiplication. Now, what do you see? Yeah, e to the power 5x, common on both sides. So I'm gonna, pull it out. So e5x, I pulled it out, right? All I left is 10 times the bracket. So 10 times 3 is 30x squared, minus 10 times 4 is 40. And I took up this one, so 12x remains, 12x inside the bracket. Yeah, and the bottom one is as it is. You can rearrange it and make it x squared, followed by this, but I'll just leave it like that. Okay, and this is your final answer. Okay, let's have a go at doing this question. Alright, this one is fx, I'll let this kx, okay? Let's have a go at differentiating the top one and the bottom one separately. Okay, the top one, it's cubic root. How would you put it back into fraction, remember? Remember this rule? Okay, let's apply it. Over here, it's x to the power 1, right? So therefore, what would it be? 1/3, right? Okay, and when you're differentiating it, 1/3 comes down and 1/3 minus 1, which will be negative 2/3. right? And the bottom will be this one, right? Oh, whoops. Okay, so since I have gx over here, that includes both of them, I'm going to let it kx and k-x for the bottom one. And there you go, this is the differential version. I just followed this formula. Right, so what I have done here to simplify this equation, okay, I have negative power. If I have negative power, that means I can pull this one down, right? So I pull this one down, so 3x to the power of 2/3 without that negative, okay? And this one is multiplied to that one, so it just became, put it on the top. So I just simplified this part. Yep, and the rest are the same. However, in order to simplify fully, just have a look at the top part, okay? This minus that, how would I have to do? I need to make the denominator equal. So I'm going to multiply, yep, the same denominator, top and the bottom, okay? And now this time I'm going to simplify this part. Okay, like this. Right, so that one, 3 times x, yep, x to the power of 1/3 and 2/3. When you're multiplying it, you're adding the power, right? So it's going to be 1. 3 over 3, 1. There you go. And this one just follows. Okay, so I have simplified this part, which means I can make this into one single fraction, right? There you go. So this is the top part. I just merge these together into one single fraction, and bottom one as it is. Okay, so this is the main fraction, a over b over c over d, right? Remember the rule. How do we do this? Here you go, remember this? So fraction over fraction, a over b over c over d. I'm going to multiply b and c, pull it down there, multiply a and d, and that goes at the top. Okay, so this is again fraction over fraction. So these two multiplied and goes at the bottom, and the top one will be multiplied, simplified, and goes at the top. Okay, just like this. I multiply these two at the bottom, again the top two, simplified. Okay, now I want you to have a go at simplifying the top one. Okay, there you go, the top one has been simplified. That one I change it back into third form, and I just left it like this. This is the simplest version. Okay, now it's mixed with e exponential equation and the third, so I want you to have a go at doing this question. Here you go. So I differentiated the top one and I differentiated the second one. Right, so if I differentiate e function, right, it will stay the same, but I'm going to differentiate the power one, which will be 2x. Okay, so if I simplify it, it will be like this, okay? Whereas gx, the bottom one, I can put this in power form. Okay, this is now chain rule if I want to differentiate it, because I have to put the power down and minus 1 to the power, which will be negative a half. But then I need to differentiate what's inside the bracket and multiply it out. So if I differentiate it, it's going to be 8x. Here you go, here's my 8x multiplied to it. So 2 and 8, it's going to be 4x and the rest. Here you go, I hope you got the same answer with me. I just follow the formula of the quotient rule, which is this. Right, it applies the same concept. So over here, this is linked with multiplication minus multiplication. So if I look at the both side, oh, I have this one and this one in common. Okay, so I'm going to pull this out from each side. And also, when you simplify this powers of power, you're going to multiply these together, and it's just going to be 1, so it will disappear. Okay? Okay, here you go. So I took up these two, write 6x, and that one, followed by minus 3 times 4 is 12x, followed by that one. Okay, and the bottom one simplified, and whatever it was in the bracket does itself. Right, on the top I have the negative power. Remember in the previous question, if we had the negative power, then we pull it down, right? Made into fraction. So that's what I'm going to do. Okay, so negative power, I just pull it down. So there you go. Everything's the same, but that one being changed into fraction. Okay, what did we do last time after this? Yeah, I need to make the base equal so I can make it into one single fraction. So I can go fraction over fraction to simplify. Right, but if I make this, if I multiply this at the bottom, I need to multiply this at the top as well. If I multiply this at the top, okay, oh, this is exactly the same thing with this one. If I multiply, powers add together, and that will be turning into 1. Okay, so that half will disappear and become 1. Okay, there you go. I just simplified this, what's in the bracket. Okay, I expanded this bracket minus this, and this is what it is. I made this one into fraction as well to make it over 1. So now this looks like fraction over fraction. Okay, and remember, if you multiply it, this will just go at the top. Alright, so if I want to do it, this one and that one will go at the bottom. This whole thing times 1 will go at the top according to the rule. Okay, so finally my answer will look like this. Okay, if I want to explain, this times that, when you multiply the same thing with the same base, you add the power, right? So 1 plus a half will be 3 over 2. And top 1 times 1, I just simplify what's inside the bracket. And there you go. That's going to be your final answer. Okay, one last question. I'll go over one of the question that includes a ln. Okay, right. You need to differentiate top and the bottom separately. There you go. So if x, a length function, if you differentiate it, it's going to be 1 over, right? But you have to differentiate what was in the bracket, which is 1, because b is just constant, right? Same with this one. That one, I can differentiate it. It's going to be 2x. However, b is just a constant, so it will disappear. Okay, now let's just apply the formula and write it down. There you go. Hope you get the correct answer. Okay, if you have a look at this one, this is again this over that. It's a fraction. However, this is not fraction, and if I make this something over x plus b to make it one single fraction, I think it will be too complicated, right? So let's think of another way. Right, if you have a look at this, it's something squared minus something squared. Remember this rule? Okay, this one, a squared minus b squared. How could we change it? If it's a and b, it's going to be a plus b and a minus b, correct? So this one, it will be x plus b, x minus b. Okay, then, that's this over that, because it's linked with multiplication. I can simplify this part. X plus b, x plus b can be cancelled out, top and the bottom, and all I left here will be x minus b, right? So if I rewrite the answer, there you go, everything's the same, but that one over here, entire one, I just let x minus b, because we cancelled out everything, minus followed by the same thing over that, okay? This one is your simplified version, okay? So there you go, we had a go at doing quotient rule today, right? I think it's more straightforward now that you know. I think you should know how to differentiate ln, differentiate exponential, differentiate trig function, and so on. However, you might struggle simplifying all these. Okay, so you need more practice. So have a go at doing some more questions from your book and see how you're getting on with the quotient rule. Okay, then I'll see you in the next lesson.